Okay, we have here an interesting integral today. I've got the integral of sine x over 3 sine x over 8 to the 2/3 dx. And you may or may not recognize this. There's been a lot of requests for this. There was a problem that I did from the MIT integration meet, and this was kind of a long time ago, like a week ago or 6 months ago, I'm not really sure. So the problem MIT had was sine 101x times sine to the 99x. So at first I was thinking maybe I could come up with a nice problem like they did, and I actually already did that. I did something that came up with 2024. But what I wanted to do was a non-integer case just to kind of show that this can be generalized and we don't need integer coefficients and integer exponents. So to generalize it, what I want to do is look at an integral. We'll say sine ax times sine bx. Right here on the MIT problem, the b value is just 1. And then we'll call the exponent on the second sine n. But there is some restrictions on n. For this to work out nice, what we're going to need is we need b to be equal to a divided by b minus 2. I think what happens when you do this is it kind of works, but then like the coefficients, the constants are all messed up, and I think it's a problem if you don't have this condition. So if you want to do this at home and try to create your own problem, this is the one thing you need to keep in mind, that you're going to need your n to be this. And if you want to do a nice problem with all integer values, you want an integer n, you just need b to divide a. And for what we're doing, there's not a lot of restrictions on it because we've got, we don't need integers. One thing I will say though is you don't want a equal to b. If you have a equal to b, it kind of, everything folds together. I don't think the formula really works, so you're going to want this, or else the whole thing doesn't really make any sense. So now to get started on the general formula, we'll start with just this sine ax. Let's take sine ax, and I can actually write this as sine a minus bx plus bx. That way I'm creating the bx we have on this other one. Notice we haven't changed it. You distribute this all out. All this stuff here is still ax. Then just using different angle formula on this thing, we get sine a minus bx cosine bx plus, just switch around the angles, and we get sine bx cosine a minus bx. And then I'll just take this and put it back into the integral in this form, just multiplying in sine bx to the n. Then doing that, just notice that the exponent changed here because we multiplied sine bx times sine nbx. Think of the exponent on that as 1, so we just added the exponents here. And then from here, what I'll do, let's kind of put a label on this thing. We'll call this f. And then what I want to do is take a derivative. So doing that out, f prime is going to be, first we do power rule, so we're going to have n plus 1 sine bx, then the exponent just becomes 1. Then we have chain rule, we get cosine bx, and a b is going to pop out. Here, I'll just leave it on the end for now. And then what we notice is this stuff here, we already have this over here. And all I need to do to make the whole thing work is multiply in a constant. So I can multiply in this b times n plus 1 on everything. So like if I multiply it in here, I'll fix it in a minute, but let's just write it like this for now. This is going to be multiplied into this stuff, and we'll do the same thing over here. But so we're not changing it. Let's just multiply by the same thing up front. And let me actually move this over because I actually want it with this stuff here. And then doing it that way, everything over here, including this constant stuff, this is going to be the same thing as f prime. And then coming over here, let's take sine a minus bx, and I'm going to call that g. And I'll do the same thing, take a derivative on it. This thing is going to become cosine a minus b x. Then the a minus b is going to pop out front as a constant. And then notice this looks a lot like this, but at this point, I don't really want this n in it. That was just kind of a placeholder. We already know n. We have n in terms of a and b. So let's come over here. So for b times n plus 1, putting it back as a over b, we can write this as b times our n, which is a over b minus 2 plus 1. Multiply this out, the b's are going to cancel, and we get just a minus 2 plus 1 minus 1. So we end up here with minus b. So b times n plus 1 is the same thing as a minus b. And so what I'm going to do is switch everything to that. We'll switch this to a minus b. And we'll just do that everywhere, switch everything to a minus b. I don't know if that part's confusing for people. I just kind of like starting with just the n for the exponent, but actually we could express the n like this right here. So then doing that, this right here is the same as our derivative here. So this is our g prime, and what we have here is the reverse product rule. So for the product rule, it's just if we have the derivative of something like f times g, then we end up with f prime g plus f g prime, just using that formula. But then we notice everything we have in the integrals in exactly that form. We've got our f prime g, f g prime, just in a different order. When this is inside of an integral, what's going to happen, we're integrating a derivative, we just get back f g plus c. So we're all set up just to kind of grab our solution. It's going to be we just need f, which is right here, and we just need g. And so I'll just make a little space to put down our solution of fg plus c. Putting this together, what we have is sine to the n plus 1 bx times sine a minus b x over a minus b, add a plus c. But one thing, let's actually get everything back, like I said, to a and b, and we've got this n in it. So putting it back, if n is a over b minus 2, then n plus 1 is going to be a over b minus 1, and that's it. So now getting back to the original problem, we just want to use the formula where a value is going to be 1/3, b value on this is going to be 1/8. So for the a over b minus 1 value, what we can do is, again, a over b is going to be 8/3, minus 1 is going to be just 5/3. So using the formula, what we get is going to be sine 5/3, b is 1/8, so we get x over 8, sine, and I forgot we should get the a minus b value, so 1/3 minus 1/8, get a common denominator, that's going to be 8/24 minus 3/24 equals 5/24. So this will become sine 5/24x all over 5/24. We can flip it and write it as 5 and write a 24 in front like this, add a plus c, and that's it. Okay, so there you go. Pretty nice formula, and it's a nice way to create seemingly difficult integrals without a lot of work. Okay, that's it for today. Thanks everyone for watching. Have a good day.